Hey everyone, welcome back to my channel. Today I'm going to be working on problem number 1305, all elements into binary search trees. Now this is a problem I have worked on before, but as you guys can see, I got it wrong. So I'm going to try to take another crack at it and see if I can get it right this time. Typically I work on this channel on problems that I have never worked on in the past, but or sometimes if I have worked on them, they were wrong submission. So I'm going to try to work on this and hopefully have the right algorithm this time. So the problem states, given two binary search trees, root 1 and root 2, return a list containing all the integers from both trees sorted in ascending order. So you have tree 1, which is 2, 1, and 4, and 1, 0, and 3. And then you have another example, 1, 8, and then 8, 1. In both, you have an output which is in sorted order of all the integer values from both trees. So the hint here is doing that this is a binary search tree. So binary search trees are best to be traversed in order because we can create lists where they are created in order. So the general steps during an interview is to highlight the algorithm and then go over any edge cases, and also the runtime and space-time complexity. So let's figure out the algorithm. But before that, let's try to read the constraints. So the constraints state the number of nodes in each tree is in the range 0 to 5,000. So, okay, and the least minimum possible value is negative 10 to the 5, and the greatest value is 10 to the 5. So the simplest way is to doing a in-order traversal. Technically, we don't even have to do an in-order traversal. We could do any order because we are going to be sorting the list in the end anyways. But let me see if that can be improved. So let's say we do 0, let's say it's 1 to 4, and then this is 0, 1, 3. Once we have something like this, or an example which I highlighted, which is an edge case. So if you look at this tree, it's negative 10, 0, 10, and then here it's 0, 1, 2, 5, 7. Once we've done that, if we were to use collections.sort in the end, that would give us O of n log of n. So there are two techniques. One technique is to do the same thing in the beginning, add everything through an in-order traversal. But if you use collections.sort, then in-order traversal is sort of pointless. But let's say we use the second technique where we do use in-order traversal and then create two lists for a certain example like this. So the first one would be negative 10, 0, and 10, negative 10, 0, and 10. Again, this is for the second technique, which we are trying to do faster than O of n log of n. And then the second list would be 0, 1, 5, 7, 0, 1, 2, 5, 7, so 0, 1, 2, and then 5 and 7. So what we would do is we would say, all right, is 10 greater or less or 0? Negative 10 is less or 0, so it's negative 10. Then we increment the pointer in this one is 0 greater than. If they are equal, then we add both. So, or we could just add 0. Increment here is 0 greater or lesser than 10, so we add 0. Is 1 less than 10? Yes. Is 2 less than 10? Yes. Is 5 less than 10? Yes. Is 7 less than 10? Yes. So we need to traverse these two lists using two pointers while the end is the start is less than or equal to both of these. So start for list 1 and then start for list 2. And that would give us the worst time complexity of O of n. So the runtime for this problem would be O of n. Because both of these lists are sorted, and we would just be using a pointer to compare the values. Or what we can do even simpler is we can insert it into a tree set, but the problem is a tree set would be all unique. A priority queue would be also sorting like a min heap. So what is the runtime of a min heap insertion? Let me take a look of that. So what if we just use a min heap directly? Let's see. So offer is log of n. Actually, we can just use like a priority queue, and we won't have to use this technique because all we'll do is we'll do in-order traversal on both of them, and then we can just add the numbers, the values inside a priority queue. And then in the end, we can just transform the priority queue into the array list. So that would actually be even faster because the insertion in a priority queue is log of n, and the space time would be O of n. Okay, so let's get started. So the first thing we need is a priority queue of integer min heap in priority queue. Then what we need to do is pass in a DFS function for root 1 and then root 2, and then we can pass in the min heap, it is empty right now, and then we can do this again for root 1, and then the second time it will be root 2, and then in the end we return so we need a list of integer list equals new array list. And in here we could just put in min heap. I think that should work. So in the end we return list. If not, we could manually add them. So let's do void DFS. So let's name this tree node root 1, and we need a priority queue. So in-order traversal, as you guys know, goes from left subtree to the root node and then the right subtree. In a binary search tree, it automatically, through the recursive calls, makes a in-order collection or in-order traversal of the um, node values. So we need, in edge case of root1, or let's name this root. If root equals null, then we just return. Otherwise, we call DFS, and then we do root.left min heap, and then in here we add min heap dot offer root dot val, and then we do root dot right, and then we add that. So that should give us the in-order traversal, and then we pass in root 2, and let's see if this works. Oh my gosh, this was supposed to be, I'm sorry, this is supposed to be 0, 1, 2. Zero, one. What is wrong with this? Negative 10, 0, 0. So what we would need to do is negative 10, 0, 2. We need to do minheap.poll. So while minheap dot is empty, we just do list dot add minheap dot poll. And that should work. So list equals new array list. What is going on? Oh, cannot find some. This should work now. Okay, so let's try to run all these sample test cases. Let's submit this. Okay, great. So the submission runtime was 80 milliseconds faster than 5.0 Java solutions. Let me know if you guys think that there was a simpler way of doing this, but I think this is the best because it has a pretty optimal runtime. Thanks again for watching, and take care. Bye.